I'm George Skopsov. I'm the CEO and founder of HQuest. At HQuest, we have developed the most direct and straightforward path to decarbonizing industrial heat. We will install our compact, portable systems at our customer sites as close as possible to their furnaces and boilers. Each unit every day will pull out 3 tons of solid carbon from 200 MMBTU of natural gas before it can be combusted. 3 tons of solid carbon, that means 11 tons of CO2 per day per system that will never be emitted. Instead, our systems each system will produce a ton of clean, sustainable hydrogen, which can be blended for immediate emissions reduction. So hydrogen was supposed to be the solution to decarbonizing industrial heat. Unfortunately, it was a big disappointment. And the reason it was is because conventional hydrogen is dirty, has a huge CO2 footprint. The way it's made, so-called green hydrogen is very expensive to make. And whatever hydrogen you make, it's even more expensive to actually deliver it to the end user. So we're changing the status quo. We address every single one of those problems. Our hydrogen is clean and sustainable, and our compact systems will generate it at the point of use, basically eliminating the costs and risks of hydrogen transportation. So in essence, what you have is a clean, affordable, and most importantly, effective decarbonization solution. The reason it's clean and affordable is thanks to our carbon material. It's actually a product that people use, they want, and really, really need. The carbon material is carbon black. It's the oldest nanomaterial known to man. It makes tires stronger. It makes batteries, well, basically work. It's a $30 billion market that's growing because people drive more, they use batteries, they use their cell phones more. But unfortunately, it has a very large CO2 footprint. Our carbons are identical in every way except for one thing. They are truly sustainable. They don't have that CO2 footprint. Otherwise, they are drop-in replacements, proven drop-in replacements for the highest grade carbon blacks out there. What makes it all possible is our transformational technology, microwave plasma pyrolysis. Basically, we use an intense microwave field to heat the natural gas virtually instantaneously to thousands of degrees. And at those temperatures, the hydrocarbon molecules literally fuse together to form carbon nanoparticles and release hydrogen. There is no oxygen, no oxidation, and therefore no CO2 emissions from the process. The technology is piloted with our strategic partner and investor, Peoples Gas. Peoples Gas has tested their pipelines with our hydrogen blends, and right now is doing tests on home appliances, stoves, furnaces, even a standby generator. It all runs right now on a 20% hydrogen blend. We have been developing our technology and applications since 2014. We have a very strong IP position with more than 14 granted patents. We have been supported by Department of Energy and the National Science Foundation, and we have significant commercial traction. Beyond carbon black, we can address many other sectors and industry verticals. But with carbon black, we have a very direct path to $2 billion in revenue over the next 7 to 10 years. Right now, all we need to do is execute. Thank you.
Could you speak a little bit to the scale of your pyrolysis process and what rates and volumes you're able to handle? Because obviously a lot of industrial heat has large use cases. So.
Right, absolutely. So when we're not looking at large scale industrial heat like cement, steel, we're looking at 190,000 manufacturing plants in the United States that use natural gas as their primary energy source, but they're relatively small and distributed consumers. You know, something like 50 MMBTU boilers. That's what we're targeting. And our systems It's basically a container that will generate a ton of hydrogen per day, 200 MCF of natural gas. It will have electricity consumption, but it will be 4 times less than electrolysis.
And just, again, as you noted, the thing that's held back a lot of hydrogen is the price per kilogram.
Exactly.
And the idea that the carbon black will subsidize or overcome the additional processing steps that you have. I'm just curious about how it pencils out.
Yeah, absolutely. I mean, so for every kilogram of hydrogen, we make 3 kilograms of carbon, and that carbon, basically, the very competitive price is $1.50 per kilogram, right? And our inputs are natural gas and electricity, and in most cases, with our business model, we actually don't have to even pay for natural gas because it's the fuel that we're decarbonizing. And in many cases, electricity is subsidized as well.
And just to follow up on that, do you believe that the carbon black market is sufficient in size to support your scaling plans?
Yes, absolutely. It's a $30 billion market. We are not targeting to make every hydrogen molecule that will ever be needed, right? We are focused on decarbonization of those distributed small-scale consumers of natural gas. Carbon black market is more than sufficient to support it.
Thank you very much.
Thank you.